Hello friends, welcome to another video from our channel. In this video, we demonstrated how to control temperature and humidity using the NodeMCU module. We used a 4-channel relay module to control for outputs, heater, cooler, humidifier, and ventilation fan. The temperature and humidity control section operates as follows. The temperature or humidity range is sent via Wi-Fi network using a smartphone or PC browser. Additionally, it is displayed on an LCD screen. This allows for the activation or deactivation of the outputs accordingly. In the following part of the video, I will explain how the program works. The temperature is lower than the range, so the heater should be turned on. The temperature is within the range, so the heater turns off. The temperature is more than the range, so the cooler should be turned on. The temperature is within the range, so the cooler turns off. The humidity is lower than the range, so the humidifier should be turned on. The humidity is more than the range, so the air dryer should be turned on. The functionality of this program is similar to our previous video on the channel, with the difference that we use the NodeMCU module to create a user interface for entering temperature and humidity range values. We define a temperature range that includes the minimum and maximum values. When the temperature is lower than the minimum, the heater output is activated, and when it reaches the average number, it becomes inactive. The program calculates the average of the minimum and maximum inputs. If the average number includes 2 decimal places, it converts it to a 1 decimal number. When the temperature exceeds the maximum, the air conditioner is activated, and when it reaches the average number, it becomes inactive. The program also receives the minimum and maximum humidity range inputs and calculates the average humidity number in the code. To account for the possibility of rapid changes in environmental humidity, we subtract the calculated average number once from 2 and add it once to 2 to reach the minimum and maximum offset values. If the humidity is less than the minimum value, the relay output for the humidifier is activated, and when it reaches the maximum offset, it becomes inactive. When the environmental humidity exceeds the maximum value, the relay output for the fan is activated, and when it reaches the minimum offset, it becomes inactive. The components are connected as follows. Temperature and humidity data are transferred from the DHT sensor to the NodeMCU Wi-Fi module. The temperature, humidity, and their averages are displayed on the LCD. The outputs are controlled by commands sent from the module to the relays. Additionally, the Wi-Fi module connects to a Wi-Fi modem or a mobile hotspot via a local network. You can enter the module's IP address in a browser connected to the same network and access the module's user panel to send minimum and maximum temperature and humidity values. The wiring between the components is described in a file that you can download from the description. Let's go to connection and code. We open the Arduino IDE and start writing the code. You can download the written code from the description. Additionally, I will provide some explanations about the code in the video. Write down the required libraries for this project. This line specifies the address of the I2C LCD and its size. We write down the SSID and password for the Wi-Fi network and set the server of the NodeMCU module to port 80. Defining pin 2, which is equivalent to D4, and the type of DHT sensor. Defining pins for relay variables. The necessary variables for temperature. The necessary variables for humidity. Defining relay variables as outputs. disabling all outputs to prevent momentary blinking of the outputs, which could lead to rapid switching on and off of the outputs. In this code, due to the use of relay modules to prevent noise susceptibility, we use high to deactivate and low to activate the relays. Starting the LCD and turning on the backlight, clearing the entire LCD, and starting the DHT sensor operation. Displaying a welcome message on the Mind Factory at startup and a 3-second delay, followed by clearing the entire LCD. The loop needed to connect to the Wi-Fi network until the connection is established, repeating every 1 second. Printing connected on the LCD, along with the IP address of the NodeMCU board. Defining web pages to be hosted on the server and starting the server initialization. Printing connected on the LCD, along with the IP address of the NodeMCU board. Then, clearing the entire LCD after 4 seconds. Saving the received temperature and humidity sensor inputs as floating numbers. Calculating the average of the minimum and maximum temperature inputs provided by the user and converting it to a 1 number in the decimal part. calculating the average of the minimum and maximum humidity inputs and converting it to a single-digit number in the decimal part. Additionally, adding the average to 2 and subtracting from the average with 2 to create the on-off range for controlling the relays. Displaying the temperature and its value on the LCD. Displaying the minimum and maximum temperature inputs on the second row LCD. Displaying the humidity value on the third row of the LCD. Displaying the minimum and maximum user input values on the fourth row of the LCD. If the current temperature exceeds the set maximum temperature, the air conditioner should be turned on and the heater off. Additionally, the serial monitor print max. If the ambient temperature is lower than the set minimum temperature, the heater should be activated, and for safety, the air conditioner should be deactivated. Additionally, then be printed in the serial monitor. If the ambient temperature equals the calculated average value within the code, then both the air conditioner and heater outputs should be turned off. Additionally, the word average should be printed in the serial monitor. If the ambient humidity is greater than the predetermined maximum humidity value, the ventilation fan should be activated, and for safety, the humidifier device should be deactivated. If the ambient humidity is less than the predetermined minimum humidity value, the humidifier device should be activated, and for safety, the ventilation fan should be deactivated. If the ambient humidity is lower than the predetermined low average humidity value, then the ventilation fan should be deactivated. If the ambient humidity is higher than the predetermined high humidity threshold, then the humidifier should be deactivated. A 1-second delay, and then starting the server. Starting the loop to handle root and storing temperature and humidity into separate variables as floating numbers. the required HTML code for the web page of the NodeMCU module. Starting the web page loop to announce the reception of the minimum temperature when the Submit option is selected.
Starting the web page loop to announce the reception of the maximum temperature when the Submit option is selected. Starting the web page loop to announce the reception of the minimum humidity when the Submit option is selected. Starting the web page loop to announce the reception of the maximum humidity when the Submit option is selected.